meeting. Right now, there's only Googlers on it.
No, that's why I didn't quit.
Okay. Marty, you want to present?
Sure.
Okay.
Yep. Let me just present my Goland. I think that's going to be the easiest way to navigate around this proto. So before I get into the API itself, just a brief context how this came about. So the origins of this API are sort of the ongoing install operator work that started a few weeks ago in seriousness and has been sort of on the boil for a few months. And I guess the primary motivation for that work is to get rid of home tiller and just improve the installation and upgrade experience that we currently have, which is not really that great. So the API, it's not really a problem with tiller itself or Helm in general. I think that it's sort of the install parameters that we have just kind of evolved organically, and it's something that we probably could have structured better if we had done. It's just kind of. Hello?
So Martin, why is it using Proto 2? I mean, you have everything in Proto 2 here.
Right. So let me get to that.
Okay.
Yeah. So currently we have about 200 parameters or so, and these are structured largely based on components. And within the component, there's not really a whole lot of substructure, so they're kind of just. So one thing is that we'd like to have more of a feature-focused API and get away from naming individual control plane components. And that's something that Sven started as a sort of a high-level objective for installing Istio and just how the Istio control plane would be structured. So we'd like it to be more feature-focused. And in addition, we have quite a bit of kind of arbitrary mapping between Helm parameters and Kubernetes resources. And that's something that really could stand clean up as well, because it's fairly inconsistent. Like the HPA mappings, for example, differ by component, and they don't all have the same set of source parameters going to the autoscaler Kubernetes resources, and then we have kind of Kubernetes resource requests kind of scattered all over the place. So it'd be nice to present more familiar looking Kubernetes APIs directly to the user. And I mean, we can discuss abstracting those at some point, but just for the sake of consistency, I don't think we want to reinvent the wheel and create like inconsistent mappings from our API to whatever it's going to.
So I got a couple high-level questions then. So is the current set of stuff described at this proto an exhaustive replacement for everything that we support today in terms of options?
So it's exhaustive in terms of options. What it doesn't currently have is direct support for the add-ons. And that's something else that is a goal of this API, is to define a way that we can reference external add-ons without having to maintain the corresponding charts.
Okay.
In our install package.
Okay, and what's the relationship between this CRD and values.yaml?
So there is a relationship. That's a very good question, and I have a very detailed answer for you. So as part of the materials that I sent out, there is actually a sheet that maps the existing values.yaml to the new API, and vice versa.
But I guess
Because-
what I meant is more in terms of once this new API is present, is there still a values.yaml?
So initially, yes, because the underlying implementation in the operator is based on the Helm templates.
Okay.
Long term, it's something we can consider getting rid of. So I think the first step is to have an API that we can migrate users to, and the least painful way of doing that is to maintain the existing templates.
Okay, so in the context of 1.2, we would document this API and continue documenting and supporting the template directly.
Not
That's
template,
correct.
the values.yaml.
No, but we would still support Helm in 1.2 template.
Well,
Yeah.
I think all of them are using Helm. I mean, the new implementation is also implementing.
We would
that
still
Helm.
support using Helm directly, using
yeah.
both Helm template and
Oh, yeah.
Tiller in the 1.2 timeframe.
And probably 1.x timeframe because we
Well,
have customers.
so let's just talk about 1.2 for
Yeah.
now. Yeah.
Okay.
Yes.
But would the long-term direction to be to completely eliminate that?
I think so. I think there's probably something that we can discuss in the long term. I think template.
I think it depends if we can get, so it's going to depend on what the users do, right?
Exactly.
Like if the users migrate to this and no one is using Helm anymore, yeah, we can get rid of Helm. If for some reason or other people still need Helm, we'll have to keep supporting it.
Keep in mind, people organization standards on a solution. Is this organization is standardized on Helm for everything? They are obviously either not use
Then
Istio or
they might want to use Helm.
Yeah, but you could use Helm to run this thing,
Yes, you could.
right? So if people really want Helm, they can continue.
Well, it's more if they don't want an operator running in the cluster, instead they want to do
yeah.
the Helm template mode and they don't want to use the operator template mode for some reason. But yeah, we have to find that out. The goal is to remove the need for a Helm.
Because ultimately, you can also run the operator as a one-shot thing, right?
Right.
So
Yeah, you can. Yeah.
Yeah,
So,
and
yeah,
you're not exposing everything in Helm through the operator, right? Because else your operator would be as big and with Helm today, which is what you don't want to be.
Well, so I think initially we kind of have to support one way or another.
So I thought with the customized thing, we were not including some of the options.
Right, exactly. So there are some options that are not explicitly in the API, but they're still reachable through using overlays, and that's actually a feature of the operator design. And you'll actually see. So maybe I can just explain how that works right now. There's a field in each feature, which is right here. So I hope you can see my highlighting there.
yes.
But
Yeah.
there's a Kubernetes object override, which is basically a customized style overlay. Customized being the with the K spelling and the Z spelling, allowing you to actually override Kubernetes level resources. So some of the parameters that we currently support explicitly as configuration parameters would end up being an overlay.
why not use customize directly?
It's not used. No, we wouldn't be using customize directly. So customize is really just under the hood. It's using
Oh, I see.
different patching libraries.
So
and
that's
Yep.
another way to use customize without their strong opinions on directory structure and operating mode.
Yes, exactly.
That's a good idea.
Exactly.
We're using the same implementation it
I see,
uses.
I see. I want to point out, I don't know if people saw the presentation in environments a few weeks ago where Shopify, I believe, was presenting their way to deploying Istio. And the way they are doing it is they check in templates, they have the templates reviewed and integrated with their CI/CD system. So I think one requirement is to be able to generate Kubernetes templates that can be checked in and, again, plugged into a custom CI/CD pipeline.
Right, that's what Helm is for, right?
Helm template, yeah.
Yeah.
So I, initially Helm template is going to be the underlying implementation of how the manifests are rendered. And long term, I think we can discuss getting rid of it. Although I think there are some attractive things about the Helm template portion of Helm. Tiller, I think is debatable how good that is, but certainly the template part of it, I think has some nice attributes.
But like I said, you can use a template to program this API, and you'll have the same effect.
Yeah, you can. I mean, this API, I think is it. I think this is more as something operator.
Well, so I think there's two orthogonal things here, right? So one is kind of the input to like in the CI/CD system, and one is the output. And the output, there's two options. One is the output is just a bunch of Kubernetes resources that then some CI system goes and makes occur in the cluster. And the other option is the operator is running in the cluster and it's doing that, right? Like it's playing the role of CI/CD. On the other side of it, on the input side, I think what we want to get to is the input is one of these CRDs, and the output can be either of those things.
Yeah. It's kind of like automatic injection and manual injection. People are going to use manual initially unless they're really comfortable with your automatic injection.
Security is a factor that will make automatic injection impossible in many environments.
Yeah.
No matter what. And it's the right thing to do, actually, to not rely on automatic.
There are reasons.
There are reasons why people, one concern about naming here, two concerns about naming. One, installer spec, I think we are focusing too much on installing Istio when really customers care about maintaining Istio and operating Istio.
Right. It's just the Istio spec.
It's a Istio spec, not installer spec. I mean, installer is once, you run it once and you forget. About 3 years later, you never remember you install it. Or it's just installed for you. But operating Istio means that you have this to fine tune while you operate. You can change the light step, you can change the configuration. So it's
should it be Istio config?
Istio config is fine, whatever. But I don't want to see installer.
Some better name than installer.
Because Istio config is awfully generic.
Yeah, it is a generic, but this is the overall configuration for all of Istio, right?
Well, no. This is the topology information about how to deploy. These are basically the options that you can't change dynamically. And it's the static config of the system.
You can change dynamically.
You can change it dynamically. What do you mean?
Yeah, you can change this dynamically. This is a dynamic API.
So I think
No, what I mean is the components that are running, the options that are expressed here are not dynamically changed in those components. You have to restart the component kind of thing, right?
Well, no, but the operator is going to restart those.
Yeah, I know.
So this is not runtime configuration for the components. This is the bootstrap or static configuration.
There is no such thing. I mean, in reality, you operate Istio, it never goes down. Istio will never restart it. You start Istio once, and then you change it. May do a rolling upgrade, it may do the CRD, but in the end, they may
the difference is Pilot is monitoring some CRDs that it cares about, and it changes its behavior accordingly.
Yeah.
These require Pilot to be shot in the head and restarted.
But user will not notice any difference. I mean, the Pilot may happen to notice to monitor those resources, or it may be restarted every 5 minutes. The user doesn't care.
Then our model is broken.
Why?
Because if there's Pilot options in here, they should be with the Pilot related stuff instead of this Mongo thing at the top level.
What do you mean?
But what is Pilot? Pilot is implementation.
What are you talking about as Pilot configuration?
What I mean is the fact that there's some component-specific configuration and feature-specific configuration that we glom together in this giant CRD. It's a reflection of the fact that these options are set statically from the point of view of the components.
I'm not aware of any static configuration whatsoever. Everything is dynamic. I mean, that's my point.
That's definitely not bug. That's not the intention, right? So the intention is that this is the configuration of Istio.
But you don't put the definition of the virtual services in there.
No, because that's not the configuration of Istio. That's configuration of the services running in Istio.
Some of them are actually some virtual services are actually hidden.
But yeah, there is a depth. So this is the configuration of the Istio control plane, let's say.
Light step is more like.
Okay, so that might.
I mean, it's like of the components themselves, not the things the components are using, right?
Correct. That's my point. So the components are statically configured at their startup time with these parameters.
Well, so I think we're all saying, please don't focus on the static part, because this all could be dynamic, and it wouldn't change the fact that this is about the component config, not the runtime config.
And nothing is static. The fact that we start something
Right.
doesn't mean it's static. It means that it's going to take effect with some
But
small delay.
I think the point you're making is that there's two different types of Istio configuration in some sense. There's this stuff which is kind of about Istio itself, and then there's what is the stuff Istio itself processes.
Yeah, so I think what you said is correct. So this is control plane config, and I think that'd be a fine name for it.
Actually, that's a very good point here.
Also have data plane too, right?
And
But
then-
is that what the rest of the config is for?
well,
Yeah, so that's why I have a
data
point-wise
plane.
question. For example, do we have the domains, like we have a command line flag in pilot for specifying a domain suffix, right? Is this part of that? Because that
It
changes the
should be. Yes,
configuration
it
details.
is. It's an operation change. You can change it at any time. Yes, absolutely. It's the fact that it's a command line flag doesn't matter. I mean, from the user perspective, it's
But I think that's where that actually goes to the other side of the line, right? So there's the Istio control plane configuration, and then there's the configuration of how we generate artifacts, right, or runtime configuration for the system, right? So, for example, that particular one I think falls into the other category. And if we capture it here, I think it will be.
Sorry, what
I
was
don't
the
think it's the right
example?
place.
What was the example again? What was the?
So there's a domain suffix flag, I think, that's being used when generating configuration themselves, like that the configuration that goes to Envoy.
yeah.
Right, but so is that about configuring the mesh, or is that about configuring
It's
the
about configuring the mesh, right?
the services within the mesh?
Right.
For the sidecasts.
But if we want to categorize, I think we should make a distinction between features that we expect or any Istio implementation to implement, like virtual service and so forth, and implementation specific features like pilot happens to support, but are not necessarily required to have a conformant Istio implementation. Because again, you may have different deployments. People may turn off some features, may use alternatives to tracing and different options to run each component. Some of those that are specific to one particular implementation, I think, should be clearly delineated from the rest.
Yeah,
If you get my
I
point.
don't quite follow that. I think it is clear we need to have somewhere written down, like, we need names, for like what we're talking about at these different parts, and then we need a guidance or guideline or something as part of the API group
Zipkin
saying
versus
what goes in this thing, what is part of the operator config, whatever the operator config means, and then what is kind of the runtime config, for lack of a better term.
Right.
Right.
So if I can use a Google analogy, right? So we have like different kind of configuration stores, right? So we essentially have a Borg internally, which is like similar to what this does, right? You have Borg configuration. Then you have like components that actually provide configuration at the runtime, where you can listen and change your behavior based on that configuration. And then there is your regular data path. For us, that is the actual Istio configuration, right? So that's the thing I'm trying to point out. Like, there's like, that's like kind of category there, which I think we are kind of lumping with this, which I think should not be here. That actually affects on how the components behave rather than the topology or.
Yeah, so semantic behavior should be controlled by regular CRDs that the components consume. This is about the lower level.
Yeah, which probably means like, if those things change, we may need to discard a lot of state and then rebuild it in, Pilot or Galley, because I changed like some DNS name, for example, and that affects like a bunch of things, right? But I think that's something that would be expected rather than restarting Pilot.
So then is this actually actively advocating against this API being feature bound?
No.
No.
That's I mean, this is saying that this is component bound, right? Like, you don't restart a feature, you do restart a component.
Pilot can change towards those resources and not restart if it chooses to, if it's convenient
but
necessary.
But that's the thing. If the delineation is that, yes, there is a class of API which is feature bound, but then there is a class of API which is actually just inherently component bound.
So this is about. I mean, it's hard. Yeah, we lack the right terms for this, but so I don't think thinking about component versus feature is useful, because we actually do want to actually even think on this part about features. But this is about whether a feature is enabled, and so like by enabled kind of installed, right? Like whether it's on, and then sort of the basic settings for that.
But it's like Mixer has 20 command line options. Things like setting cache sizes and then timeouts and ports.
Yeah.
Those are definitely component things. They're not feature things.
Right.
I'm starting this component. I want to describe how its basic operational parameters are. So there's a
so there is need for somewhere to put that stuff. Yes.
So right now, the way that I've structured this is it is a mix actually of feature and component, just because some things are more naturally bound to components rather than features. But I've grouped the components under at least features to begin with.
Okay.
So for example, the traffic management config actually has some component sub.
Oh, interesting.
Pilot and proxy and sidecar injector.
So can you point out some specific features things? That's because I want to understand.
So like the example right here
sampling
is the namespace. Well, no, okay, that's component.
Yeah, so trace sampling is definitely a feature thing, but it's expressed in a component thing.
Okay, but that's thick. So why does this have any feature specific stuff? Shouldn't that just be a CRD?
Those are CRDs. I mean,
it does have. It does have. I mean, so for example, the security config. If we look at that, so something like control plane MTLS. It's not really component based.
Yeah. Yeah. So that's fine.
Trust domain. I mean, other things are currently I've put these as features, but you could probably restate these as, I put them currently as component, but I think you could restate these as just feature and just do away with Citadel, for example.
I'm possibly changing my mind here a little bit, live action style. It does seem, actually looking at this, that it is almost entirely component configuration, right? Like we're talking about, and that would be a possibly useful model of how we think about what goes where. That this is where we put component configuration, the components of Istio, what components are installed, what components are running.
What is a component of Istio? Istio is a platform that supports a number of APIs. You may run different implementation of Istio. Each piece, I mean, Zipkin, there are 5 implementation of tracing. There will be 2 implementation of Mixer.
Right, but the configuration here is about what component do you use for tracing?
But that's yes, that's true. But it's also internal implementation about how Mixer is doing. I mean, if we have Citadel, we have all kind of component names that maybe we should separate the actual configuration of components that are completely separate, implementation specific, and the main choice that I want to.
So I think what I'm trying to say, and again, I'm thinking out loud here, so give me a second, is that like if we had the mental model of the operator config describes kind of what components are installed and enabled, and then you have separate CRDs to describe the behavior of the system, right? Like what security, what are the global security settings, right? What are the global settings for policy, et cetera? Like, should we mix those in one place? Should we try to separate them out? Yeah, I think that's.
Again, to me, the mental model is, the line is pretty simple. If the component, so let's push this to an extreme. You could say all CRDs in Istio are in this file, and when any configuration changes are made, you have to restart the components because they're not dynamic in nature. So clearly that's stupid.
Why?
All right, so I think we want to be in the other extreme as much as
we don't want people to edit one file.
Yeah, I want to change. There's that one setting I care about. I want to change that. I don't need to run Helm. I don't need to run this operator. The component will pick it up and deal with it. This should be just about the stuff that's, again, I go back to the term static configuration for the individual components that are running.
Well, let's call it component config because a lot of it is actually dynamic, right? Like if you turn on MTLS for the control plane, we actually want that to roll out.
In a gradual way.
In a gradual way, but the operator can control it, right?
But the rollout is done by
the operator,
but also by restarting the components.
Maybe not. I don't think that has to be that way, right? Like that's an implementation detail.
Okay, so then are you saying that the point of the operator is to orchestrate config changes,
Yep,
Yes.
absolutely.
but of the control plane, not of the data plane configurations.
I have the components.
Right, of the components.
For example, MTLS setting affects the data plane. If you choose to change to secure mode and gradually move from permissive to
So actually having, yeah, okay. So there is some interesting stuff in here where we have some instances of globals that probably don't belong here.
Oh,
But we don't have anywhere else to put them. But like,
Correct.
so data plane MTLS probably is not something we want in.
well, we want it
We have,
somewhere.
we have mesh config for globals also.
Mesh
Right, but
config
so I think
anymore.
some of what this is trying to do is also provide a input to generate mesh config, and so we have to figure out the relationship
I think
there.
this is replacing mesh config. Mesh config was not used externally since 0.8. We have values.yaml, which is mesh config.
But
This
mesh
is trying to
config is on
replace values.yaml.
Istio.io.
It may be, but it doesn't mean it's used.
It's not editable.
It's not editable by user. The
I mean,
user
like,
interacts with
physically, you
values.yaml.
cannot edit it easily.
So there is some, okay, so there is some feature configuration here. So maybe what would make sense is to first, like as a straw man, just try to see what it would look like if those are completely separated.
Yeah.
The sort of component configuration from feature configuration. So things like whether, like what the default is for MTLS, which it seems weird that it says Boolean, but, and like what the trust domain is. Like those are not component configurations, right? Those are
Global
Those are mesh.
Istio configurations.
those
Yes.
are mesh
Yeah, mesh
configurations.
configuration.
So are you saying just have one set of feature-based config parameters and
Well,
then
so we should
everything
like
else is-
just as an exercise split them out. I don't know, just in a doc or whatever, and just look at them in isolation.
So
And what are the component things? So like what namespace to install something in, what replica count, whether that component is on or not, right? Like clearly those are all component configurations.
and which
then
components
things-
to use? Yes.
Then things like trust domain and whether
Yes.
MTLS is on, those are features. And so we should
I agree. That will be
see
super
about how to
useful.
separate them.
And the component-based configuration can use names like pilot, citadel, whatever, and the should never refer to any component by name. I mean, you should never say that it's citadel or pilot that is providing MTLS or control plane MTLS. It's, Istio mesh config is providing that.
Okay.
So
Can
I think it's somewhat already expressed along those lines. I don't know what in addition to this you're looking for, Sven.
Well, so just that it's mixed right now, right? Like
Yeah,
you
but
have
if you look
namespace,
at the-
which is a component config right next to data plane MTLS, which is runtime config.
And citadel config, which is citadel specific, component specific, because you use citadel, versus trust domain, which is a global config that can work with any authentication.
And I think there's a separate question here, which is like, do we actually need, is it a requirement that we only have one top level type, one top level CRD, or could we have
Per
multiple?
namespace. And per namespace.
For the installer, for the operator.
Yeah, for the operator.
Yeah. So
I don't think it's a requirement that there's only one, right?
yeah,
You could
'cause
read
this,
for multiple.
This file is ginormous. It would benefit from being in separate chunks, I think.
Okay, one small comment here before we forget, because that's an excellent point. Keep in mind that we are trying, at least for the environments working group, one of the goals is to move to a gradual upgrade where we don't have any global mesh config. We have a stable production config. We have multiple environments, each with different configuration. We gradually shift from one to another. So, and we also want to have per namespace config. So each namespace.
Oh yeah, of course. This is all.
So everything we are talking here should be per environment, what we call in the current installer, meaning that namespaces will kind of point to a particular environment or be able to override specific settings in some way. Because customers want to shift gradually to new configurations. They don't want to automatically kind of turn security on or to turn anything on.
So I have a question. What do you mean by environment in that context?
Environment is a set of configuration, set of components. You have, for example, production environment that is running Istio 1.0, and you have an environment running Istio 1.1, another environment using Istio master, and you have another environment with Istio master with MTLS on. So you have different preset mesh configuration with different components, different whatever, and at runtime, the namespace can point to one of those environments.
So it's a way to subset a mesh into like these option sets.
Yes.
That's all. But it is still one mesh, still the same
They
root
can
of
talk with
trust.
each other.
Right.
Have different
But
characteristics.
everything else can be different.
Okay, I'm confused now. I thought you were talking about the control plane components in that context, right? So I actually deploy control plane components in those environments separately, but the taxonomy doesn't apply to the control plane components. Then it's just my staging or my
No.
production environment.
It's a full set of configuration because you want, for example, one control plane environment to have strict mode or to use SDS for secret discovery. So it's a completely different set of options. You may want to. I mean, that's how you gradually adopt options.
So you can.
Okay, but I think Oz is pointing out there's two different things. There's using environments for different versions of Istio or configurations of Istio.
Yep.
As opposed to the applications that are running on top. This is my staging environment versus my production environment. That's a different.
They're all orthogonal. I mean, you may have an application point at a particular environment and then shift it another production environment as you shift configuration.
Yeah. So what I was trying to understand is which one were you referring when you said environment?
Both. Meaning that an environment is a configuration of Istio with a set of everything.
It's like an installation of Istio.
Installation of Istio, but interoperable. Each environment is interoperable, meaning that
You can install Istio multiple times in one mesh.
yes, but all the workloads can talk regardless of which control planes they're talking with.
So again, question number 2, does that mean, is it bound to a single cluster or the configuration it can apply across clusters? Right?
Yeah, absolutely. That's one of the reasons. It's multi-cluster by definition, yes.
Right,
But
so
in a
I should be
single
able to
cluster,
get one instance of this file applied into different clusters and they should be able to operate in unison as a part of the same mesh, right?
I think so. Let me see if I can try to take this. So one instance of this file, if you install this plus an operator into a namespace, that is an instance of the Istio control plane. Let's just call it for now.
Right.
Any namespace within a mesh of clusters can point to any of the different control planes running in that cluster, in that mesh,
regardless of where they run.
regardless of where they run.
So my point is essentially I have a master file that describes my topology of all of my mesh, right? Just for the sake of argument. And then I can go and say, okay, I'm going to deploy to namespace foo, and the namespace foo section of this master deployment plan or master Istio configuration applies to that control plane. Is that how it's supposed to be set up?
Yes, and in different namespace, you set up bar where you have a completely different set of settings, different version, different everything. And then the namespace can choose which environment to use.
So then essentially I have a single file, I can look at this file, I can look at my topology, and I can validate my topology as well, right? So I can say, hey, I have MTLS here, but not here, so that's going to be a problem.
So that's not in one file, that's in two separate files.
So
Each control plane has its own file.
Yep.
Okay.
Because they're different.
The namespace has to specify which environment to use.
So, but essentially, all you're doing is essentially creating a file format and then saying namespace foo colon this file.
Yep.
And namespace bar saying this file.
Yeah.
In effect, yes.
Okay. 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 So can we talk a little bit about the Proto 2 versus 3 thing?
Yeah, sure. So I started off with Proto 3 actually, and what I realized was that Proto 3 uses for scalars, it doesn't use pointers, it just uses the actual type. And what that means is that you can't specify unset. It's just not possible.
Yep.
And where that becomes a problem is where you have some set of defaults. Let's say you have some installation profile, and now the user would like to override that by specifying something in this CR. For example, if something is by default enabled, let's say a feature is enabled in the default profile, and the user wants to disable it. So they would say enable false.
We want to know what the user actually set versus what it's just its default. Yes.
Exactly. Yes. So I don't know if there's a way of working around that.
That's why we added the wrapper types. Yeah.
Okay, but why is this different than all the other CRDs?
Because other CRDs are not really and sort of an overlay over a set of defaults. They allow like a complete specification of something versus there being. Well,
that's not true. The fields can be optional as well. Right?
No,
No,
but there is
not in Proto.
the merge
Or not
semantics. Okay,
Yeah.
so the merge semantics here are kind of explicitly. I mean, we expect people to use merge semantics here, whereas in our normal CRDs, the merge is defined at the API level. It's not like it's never going to be the case that we're going to have two virtual services being physically merged into one and then interpreted by the API.
exactly.
Whereas
Yeah,
in this
exactly.
case, we will have two of these physically merged and then interpreted by, I mean,
When do we have two of these merged? I don't understand.
So we have kind of a default, so an implicit default for an installation.
Okay. But
And that's merged with, and that has to be merged with whatever the user set.
But every CRD has, you don't have to specify all fields when you're initializing a CRD.
Yeah.
So they'll just default to the default. So the idea here is you need to arrange it so that the default configuration, the default variation of this is what we want.
Right, but we're going to actually change defaults across versions, right? And you can't do that in Proto.
It's actually not possible to do that because in some cases it's your default is indistinguishable from the default value of the proto itself.
Right,
So
isn't that a bit dangerous, right? So from deployment to deployment, my behavior can change and I can not see it in the file, right? So whereas if there are stable defaults, by looking at the file, I know what the value is going to be.
So yeah, I mean, another possibility is to require the user to fully specify every field with the default that we provide.
Well, so I think that's not quite what I was saying. Saying that once someone has installed Istio, right, whatever default they got, that default sticks around regardless of updates, right? That we don't have the need to change those things because that would actually change behavior.
Right. It's a breaking change.
Well, that's not necessarily true though, because they may want to start with some feature and then also component and then decided to add or delete them.
Yeah, but the point is the installation, when they install the next version of Istio, the things that were default before, if we change what that is now, their behavior of their mesh would change.
Right, but they still have the capability to change them if they want to. Okay, it's just the upgrade portion. We'll honor whatever their old default is.
Yeah, so somebody didn't specify TLS and they were happy the mesh was working and we decided, oh, the new default is TLS is enabled. Stuff stops working when they upgrade because they didn't have to specify the default.
But, so I think that's up to us to make sure that something like that does not happen, right? That's just like upgradability hygiene, really. That it shouldn't just
so using Proto 3 would kind of force us to deal with that in a fundamental way that the using Proto 2 doesn't force us to do.
Exactly.
Like it's easier for us to screw people over using Proto 2.
Yeah.
Yeah, I think if we decide that we need a sort of a merge operation, I don't see how we can cover all the field types with Proto 3.
We can. So if there's something that we explicitly want to track unset, we can use the wrapper type, right? That's what it was created for.
Or you things like 0 is an undefined value, and then 1, 2, 3 is something useful.
Well, yeah. So no, it's for things like booleans, right? Like a boolean, you need to use the wrapper type. So there was a 6-month discussion in the design of Proto 3, right, around this topic that led to the creation of the wrapper types. So there is a solution as part of Proto 3 for this.
So the other thing we should note is that we are using Proto 3 or 2 just as a convenience, as a schema descriptor.
Yeah.
This could have been JSON schema, right? Like we're using it as a convenience. So strict Proto merge semantics don't actually have to apply. We can have the merge.
We can do it at the JSON level.
Yeah, we can actually do merge at the JSON level, which does look like Proto 2 then, because it has the patch semantics are
right. Unset is tracked. Yeah.
Unset is not there, and that's what values does. So if you look at what Helm does, that's how the values are getting merged.
But if some of these things are going to be CRDs, I think there is value in trying to have a uniform model with in the data model, right? So As far as I know, this is going to be the first proto that we're going to have to deal with, which is going to be different compared to everything else that we deal with today.
Yeah.
So I would recommend we go back to Proto 3 and we explicitly look at which fields we think we want to track unset for, and let's add and let's discuss, and then let's add the wrapper type if we need to. Yeah. And if it ends up that is every single field, then okay, maybe we should talk about Proto 2.
Okay. Yep, that's fine. Yeah, I think the wrapper fields will allow us an out if we need it.
It's an explicit out at that point. Yeah.
That's implementation detail, and users will still interact with YAML files.
Right.
Yeah, because the nice thing about the wrapper types is that they get collapsed when you render them, so that you don't have to write a wrapper.
Oh, you okay?
In JSON.
Yes.
Again, by design.
Right. Yeah. So that's getting some of the Proto 2 features back into Proto 3, right? Like.
Yeah. All right. Yep. I'll take a look at that.
And if anyone is really interested in this topic, I can give you about 30 docs.
All right. Well, shall I go over some of these messages, some of these components, or no?
Oh, so I had a question. So I mentioned a separate comment before about adapters and how to deal with those. And I'm not sure what's the right strategy here. So you had a couple adapters called out originally in your doc.
That's a good question.
So are you talking about, for example, these telemetry config adapters?
Yeah, you had standard I/O and
yeah, those exactly those. Yep.
Yeah, exactly. Kubernetes env. So fine. Right now for the Kubernetes env, it says it's turned on. So I guess that ends up still being effectively component level config.
It actually blurs the line. So it's expressed as component, but the intent is the feature.
So why do we have for a Kubernetes environment, why do we have that knob?
You may not be running in Kubernetes environment, and then
can't we just auto detect that and not?
But
there's something
that's controlling which config gets installed.
Right.
Which CRD is populated downstream. Right. So it's setting the defaults for the runtime parameters, the runtime state. And it's the same for the other adapters as well. So it's getting different with Mixer v2 because now we also have the question of not only do you want to enable the config, but you actually want to deploy the adapter in your cluster.
Yeah, it would be nice. So taking Prometheus just as an example, it would be nice to not have Prometheus here and wherever else it is in this, and instead have one place that it's set up.
So this is the only place where Prometheus is mentioned. The existing Prometheus configuration, the plan is to just reference the Prometheus operator to install that.
Okay.
Yeah, and that's expressed generically in this file.
So I wonder if there's a more generic way we can express add-ons than nested under telemetry config as an adapter config.
I'm not sure. I think that's it's kind of a mix or a telemetry question to me.
It's not really a telemetry question, right? Yeah, it's just a general organization question. Whether for example, again, taking a feature-centric view, right? If Prometheus is the feature, it doesn't matter whether it's provided by Mixer v1 or Mixer v2. You want your metrics exported in Prometheus.
You just want to say, please use Prometheus. Here is Prometheus, right? Here's the address or whatever. Yeah.
Right.
If I'm running the operator and I say I want to turn on the standard I/O stuff, where does the config come from to populate that? The CRD definition?
Are you saying where does it happen now, or where will it happen in the future?
In this world with the operator, where does that CRD state come from that it's going to push into the cluster?
So they have this file, right? that says, Prometheus enabled or whatever.
Yeah, but there's a CRD behind that.
I know. Hold on. I was going to explain. So the operator will take that and translate it into a values.yaml file that it will then run through Helm template, which will generate all of those CRDs, and then it will go and kube control apply those to the cluster.
So the actual CRD then is defined in the Helm template?
Yes.
Mm-hmm.
So the CR. So the
that's an
Helm
implementation detail.
Right.
That's
Well, yeah, but the thing is, so if I'm messing around with this stuff, so that's a dynamic change that it's going to do stuff there's an actual CRD. Once the system is running, the user is going to look at the cube env CRD to make changes in the behavior of that component.
Correct.
Not here. But here, if I diddle some options in here, it might actually be overriding my CRD that's in the cluster.
Yes.
Yeah, so I think that's kind of broken.
So that I think that is something that Kustomize addresses a little bit, because it means that if we don't want to expose any of the underlying APIs ever, then they can all be exposed at this level. But I don't think we want to do that.
Well, so I think there is a very important point here, which is if you give users two different edit routes to the same file, it's a problem.
Correct.
So it would be nice if there were kind of CRs, actually not CRDs, custom resources that are owned by the operator, and the operator owns them and is responsible for editing them, and you have to go through this to do it. And there are other ones that are owned by the user, and they can go edit it, and we should not mix those.
Yeah.
So if they are editing operator, they shouldn't edit the custom resource directly with Kubernetes, else it's the two.
Right.
Exactly. So that goes again to the difference between programming the control plane versus programming features of the data plane. These are data plane features.
Mm-hmm. So yeah, I agree. This is actually even more specific than that, right? What all this is saying is that what all do you want to be enabled by default, but they're all runtime features. So this is only going to decide whether to install the stdio CRD or not. Once it is installed, the operator is free to change the behavior in that CRD, because the CR is our API.
Not necessarily. Because the operator is also going to control those and on upgrade and stuff, make changes to them.
To CRs?
Yeah. Right. It'll rerun, it'll get a new values.yaml, it'll rerun Helm template, it'll generate new ones, and it'll kube control apply them.
No, but I think for these kinds of things, this needs to be driven by code.
Right. Yeah, right. I mean, so yes, in kind of an upgrade scenario where there is like specific transformation that we need to do to.
So the model we had been assuming, or at least I had been assuming, is if someone goes in here and changes output as JSON on standard IO in here from true to false, that will result in that actually changing in the cluster dynamically.
Yeah. So
I think that's.
I think the behavior you want here is to make those so they're just enabled Booleans, period. Everything else, you go and mess around with the CRD that's in the system. And this probably, in fact, controls another flag different than the CRD that's kind of an override that says, and globally, we're turning this feature off. Globally, we're turning it on. There's a CRD there that if it's on, this is a CRD we're going to use for it.
Yeah, I mean, the only concern I have there is around just the user experience that we're creating, which is you have to go and do this thing in multiple places, right?
Yeah. And how is this simplified in Helm today? That's the other thing I'm struggling too. Because the Helm today is kind of also you configure different configuration into each subchat for pilot or proxy, which is cycle injector, and also telemetry and policy. Now we're asking user to deal with so many CRDs and the customer resources. How is this simplified other than install it for you?
Yeah, because I think the alternative, right? The alternative here is you say, okay, Prometheus, we have a higher level API, then the adapter API or whatever
Yeah.
that CR is, and it's defined in here somewhere, and you only use that and you don't touch the other one. Right? I think that's the alternative. Like we definitely can't have a please touch both option.
Correct. So in terms of the value of this layer, in my mind, is this provides a mechanism that it's a continuous running thing, and it provides us a place to have logic to deal with upgrades. That's the main value I see in this.
Yeah.
Right. So it could, even there's nothing in here about Prometheus, it understands that I'm going from V1 to V2, and I need to go diddle any Prometheus resources in the cluster. Right. That's very valuable, I think.
Is it because we keep track of the before and after and easy for rollback?
That would be a good place for it, yes.
Yeah, because the Helm does, once you generate template, you apply it, we can do that too. I guess it doesn't handle rollback nicely or version nicely.
But it also, with Helm, you don't control the rollout. Or I need to update this component first and wait a minute, and then I'll update the other thing.
I should point that the new installer, we kind of do, because we no longer install all Istio at once. We install each component individually, and we roll changes to each component independently. And each component is actually running in different namespace. Like you can update telemetry.
Can run it different.
Does run for security reasons. So that's one of the changes. You could.
It's an option. I'm saying it's an option.
The default is to run components in different namespace for security, and people could run all of them in a single namespace if they don't care about security. That's kind of the. But even if they run in the same namespace, they are independent deployment. So you deploy Mixer, telemetry, independent of this Mr. Policy, independent of Pilot or Galley or Cyclone Injector. Because
starts again looking like subcharts, but
it is not. We basically moved all the subcharts to top level charts.
So I think since we only have a couple minutes left, it's clear we identified a very interesting problem that we're not solving, or we haven't quite solved in this meeting, that I think we need to continue discussing, which is this split between kind of component level, top level configuration, and then the runtime configuration, and how we want to manage that from an install and upgrade perspective, and how we want to do things like enabling Prometheus versus settings for Prometheus. How many APIs do we offer? What does that look like? What is the right mechanism for us to make progress on that question, independent of getting, like, should we downscope the installer to just on the core component stuff? And then try to make progress there, or how do we want to deal with this?
And I wonder, is it also acceptable in this pattern to have things that are install only? You do this once, and then it never looked at again. So it's basically establishing the defaults that is used.
There is nothing like that. That's the problem. There is nothing like that. It's always
anything that is
no,
like
you could decide there is.
No, but
right. I think that so far we don't have anything like that.
Yeah, exactly. So, but we could decide these Prometheus things, for example, that's only sets the default when you're first setting things up. After that, you go talk to the CRD. Right? That's a valid model.
I don't think it's something we want.
That's not really consistent with the operator model.
right.
With how people operate Istio.
We could, I'm not disagreeing that we couldn't. That is not technically possible.
So Lynn, I have a comment on something that you asked, right? So even if nothing else changes, this actually explicitly schematizes, in some ways, values.yaml, and it just makes it more discoverable. So that's kind of almost step 0, which is valuable in itself.
And I think we need to iterate a bit more, because we identify all kind of issues. I mean, we know values.yaml had a lot of problems. I think this
makes it more obvious because of the schematizing it.
Yes, schematizing makes it obvious. Yes.
Yeah, it makes the problems more obvious. I think values.yaml, people just dumped in whatever they wanted, right?
That's true. This definitely has more control too.
Right.
And we can generate nice docs from this automatically.
Exactly.
Yes.
Right.
Okay. And
one comment on that is, this really was an attempt to synthesize the existing values.yaml, and I as part of that, I did notice that there are a lot of problems in values.yaml itself.
Yes, exactly.
And I think that's also something that should be looked at as a cleanup action, because that values.yaml is something that has just grown organically, and it's evolved in something that's kind of difficult to render into a nice API.
Right.
So this is kind of an attempt, but it's not easy.
All right, so should we meet again on this next week? not the.
Yeah, so meta things. So next week, Scott
we're
asked for the API related stuff to be reviewed. So we can prioritize and
some
maybe
of us will be at Service Mesh Day next week.
Yeah.
Okay.
We can't be here anyway.
Okay. The second meta thing is I'm not sure you guys were able to get these documents to review in time. I tried to publicize it as much as I can. So is there a better channel for me to, publish the agenda beforehand? I use discuss as the main thing. This is like the TOC topic.
Yeah. Well, I got it. So.
Okay.
I mean, I think API changes, especially big ones like these, announce is also.
What topic area did you use on Discuss, by the way? Just so
TOC. I use the TOC topic in Discuss.
Oh, why did that not email me? Okay, I don't know. I thought I had email notification set up to send that to me, but maybe not.
So please let me know if there's a better channel, medium, birds.
I think that's what we got right now.
Okay.
I think it's fine.
Okay.
Yeah, I mean, I'm not. I think actually this discussion was great. So I'm not. I don't think it was bad that some people didn't have the full context yet. It's fine.
Yeah, it's very useful. Thank you, Martin, and persevere.
Yes, keep
right.
pushing.
Thank you.
All right.
We want this fixed.
All right. Thank you, folks.
Thank you. Bye.
Bye.